Find the equation of the line that passes through the origin and divides the segment intercepted by the axis on the line 2x plus 3y equals to 6 into 3 equal parts. Let's try to understand the problem graphically first. For this, we're going to consider the xy coordinate plane. So here, let us suppose we have the line L1, and this line L1 intersects the x-axis at the point A, and it intersects the y-axis at the point B. Now clearly OA here, that's going to be the x-intercept of the line. We're going to denote it by the letter A, and OB, the distance of the point B from the origin, that is going to be denoted by the letter B, which is going to be the y-intercept of the line L. And now we also have two more lines here. So here we have the lines L2 and L3. Now these two lines are passing through the origin. The origin has the coordinates 0, 0. So let's say L2 intersects the line L1 at the point P, and the line L3 intersects that same line L1 at the point Q. Now it's given here that these two lines L2 and L3 intersect L1 in such a way at P and Q such that it trisects each other. That means the length AP is going to be equals to PQ. This is also going to be equals to PQ. With the help of this information, our goal will be to determine the equation of the two lines L2 and L3. So to begin with, what we'll do, we're going to consider the intercept form of the line. So let x over A plus y over B equals to 1. This is the intercept form of the line. So we're supposing that this is the equation of the line L1, equation of the line L1, where we have supposed A to be equals to OA. This is the x-intercept of the line, x-intercept, and then we have B is going to be equals to OB, so that is going to be the y-intercept of the line. This is the y-intercept of the line. Now, in the next step, what we'll do, we're going to define the coordinates of point A and B. Now, that's an easy task. Coordinates of point A is simply going to be A, 0, and coordinates of point B, that's going to be 0, B. Now, let's note it down. So, A has the coordinates A, 0. B has got the coordinates B, 0. Now, in order to find out the equation of the two lines L2 and L3, we will be taking the help of the two-point form of a line. So the two-point form of a line is given by y minus y1 equals to y2 minus y1 divided by x2 minus x1 whole multiplied to x minus x1. So here we have 2 points x1 y1, and we have another point x2 y2. So if a line passes through these 2 points, then the equation of the line can be obtained by taking the help of the two-point form of a line. So that means since we already have the coordinate of the origin, our goal will be to determine the coordinates of point P. So that's going to help us obtain the equation of line L2, and once we have the coordinates of point Q, we will be able to obtain the equation of the line L3. So let's begin by first finding out the equation of L2. For this, we'll first try to find out the coordinates of the point P. Okay, so let us begin by computing the coordinates of the point P. Okay, to do that, here we're going to make use of the fact that since the point P divides the segment AB in the ratio 1:2 internally. 1:2 internally. That's because we already mentioned that P and Q trisects AB. So that means AP, PQ, and QB, these are all divided into ratio 1:1:1. Now we want to consider the fact that P is dividing AP and PB into ratio 1:2. So here we can say that AP divided by PB, or we can say the ratio of AP to that of PB, this is going to be 1:2. So that is what we will be using here, and we'll be using the internal section formula to obtain the coordinates of point P. So the coordinates of the point P using the section formula, what we'll do, we will take this as 2, this is PB, and AP, that's going to be 1. So first we'll take 1 and multiply it to the x coordinate. So here I have made a mistake. So this is actually 0, B. That is the coordinate of the point P. So here 1 is going to get multiplied to the x coordinate of 0. So we have 1 times 0 added to 2 is going to get multiplied to the x coordinate of point A, divided by the sum of the ratios. We have 1 plus 2 in the denominator. Then to find out the y coordinate, we'll take 1 and multiply it to the y coordinate of the point B. So we have 1 multiplied to B added to 2 times the y coordinate of A. So that's 0, divided by 1 plus 2, which means that the coordinates of point B comes out to be 2a over 3, comma, we have b over 3. Fine. So we have obtained the coordinates of point P. So now we are ready to find out the equation of the line L2. So equation of L2, that's going to be, so we have y minus 0 equals to, we'll take b over 3 minus 0 whole divided by 2a over 3 minus 0. This is going to get multiplied to x minus 0. So we have considered the origin with coordinates 0, 0 and the point P with coordinates 2a over 3, b over 3. So we get y equals to b over 2a multiplied to x. So this is going to be the equation of the line L2. Okay, so we have obtained the equation of line L2. Now we will find out the equation of the other line, which is L3. So let's begin by computing the coordinates of the point Q. To find out the coordinates of point Q, we're going to take again the help of the section formula. So here this time we will say that Q divides AB into ratio 2:1. So in essence, we are saying that the ratio of AQ to that of QB, that's 2:1. Okay, now coordinates of Q, that is going to be equals to, so we take 2 and multiply it to the x coordinate of point B. So we have 2 times 0 added to 1 is going to get multiplied to x coordinate of point A. So we 1 multiplied to A, divided by 1 plus 2, the sum of the ratios. Then the y coordinate is going to be 2 multiplied to the y coordinate of point B. So 2 times B added to 1 multiplied to 0, divided by 1 plus 2. So solving this, we get A over 3, 2B over 3. So this is going to be the coordinates of the point Q. So now we're ready to obtain the equation of L3. So we have y minus 0 equals to 2b over 3 minus 0 whole divided by a over 3 minus 0. This is going to get multiplied to x minus 0. Fine. So we now have y equals to 2b over a multiplied to x. So this is the equation of the line L3. So now we have successfully obtained the equation of both line L2 and L3. So for line L2, we obtained that y equals to b over 2a times x. For line L2, that's y equals to 2b over a multiplied to x. And our final task will be to obtain the value of a and b. That's a very simple task because we are already being provided with the equation of the line 2x plus 3y equals to 6. Okay, let's do that. So we have 2x plus 3y equals to 6. So let's divide throughout with 6. That's going to give us x over 3. Added to y over 2 equals to 1. So here when we compare it to the equation x over a plus y over b equals to 1, we get a equals to 3 and b value equals to 2. So let's talk about line L2. Y equals to b over 2a multiplied to x. So let's substitute b and a with their respective values. So we have 2 divided by 2 times 3 multiplied to x. So this gives us x equals to 3y. So this is going to be the equation of line L2. And then we have L3. So L3 was y equals to, so we have 2 times b over a multiplied to x. So y is going to be equals to 2 multiplied to 2 divided by 3 times x or simply put, we get 3y equals to 4x. So this is going to be the equation of the other line, L3. Now both of these two lines are going to pass through the origin, and it is going to trisect the line 2x plus 3y equals to 6.